All right, let's talk about what happens. We've talked about what happens when your vertex is on the circle. We've talked about what happens when it's in the center. We've talked about what happens when your vertex of your angle is just inside the circle, not on or in the center. So that leaves the only other option is if your vertex is outside of the circle. And that can happen when you have either a tangent and a secant intersecting. So notice here, here's a tangent intersecting a secant outside of the circle. Or if you have two tangents intersecting, notice here's a tangent intersecting another tangent. Or if you have two secants, so again, here's a secant intersecting another secant, and again, the vertex outside the circle. The property for angles outside of the circle is that the angle, okay, equals 1/2 of the two arcs subtracted. Each of those creates two arcs. And you're always going to want to do the big arc minus the small arc. So notice each of these, when they intersected the circle, created two arcs. This one had an arc here and here. Okay, this angle, even though they just passed by, they still created two arcs. They created this big arc here and the smaller arc here. Those are the two I would subtract. And in this case, notice as they intersected the circle, an arc was created here and an arc was created here. So when you do the subtraction, you always want to do the bigger arc minus the smaller arc. If you don't, you're going to get a negative number, which isn't going to make a whole lot of sense. Okay. So again, and that's our property for any time you have an angle with a vertex outside the circle and you're trying to do angles with arcs. So here we have an example. We want to find the value of x. Well, x is the measure of this angle P. And as I look at angle P, I notice its vertex is outside of the circle. I also notice when it intersects the circle, it creates these two arcs, one here that's 98 degrees and one here that's 174. So I just take out my formula that the angle is supposed to be equal to 1/2 of the big arc minus the little arc that it created. Okay, so in this case, my angle P, which was x, is equal to 1/2 of the larger arc is 174, that's bigger than 98, minus the little arc, 98. I go ahead and do my subtraction. Now don't get these confused. Outside you use subtraction. Inside we used addition. Outside we use subtraction. So I have 1/2 of 76. 76 divided by 2 gives me 38 degrees. So I was able to find x is 38 degrees. All right, here are two more examples. We're asked to find the value of x. And as I look at these, I take a look at what do I have? Well, I have an angle here at L. When it intersects the circle, it creates two arcs, an arc here and an arc here. Okay, its vertex is outside of the circle. So I know the formula I'm supposed to use is that the angle is equal to 1/2 of the bigger arc that's created minus the small arc that's created. So let's put in our information. What's the angle? Well, this time they gave us the angle. The angle was 25 degrees. This is why you don't always just want to subtract and divide by 2. You want to set up the equation so you know exactly what you have. The bigger arc, which arc is bigger? Well, the 83-degree arc is bigger. Minus the small arc, which was labeled as x. I'm supposed to find x. So this isn't as easy as subtract and divide by 2 because our x is one of our arcs that we're solving for. Well, what I am going to do is I'm going to multiply both sides by 2 to get rid of that 1/2. And that gives me 50. 2 times 25 is 50 equals 83 minus x. I'm going to solve for x, so I would subtract that positive 83 from both sides. Okay, when I do that, I get negative 33 equals negative x. So that means that divide by negative 1, x is 33 degrees. Okay, so again, don't always just subtract and divide by 2. Set up the equation so you know exactly what you have and what you're looking for. Okay, we have a second example down here. Find the value of x. So I have an angle. Its vertex is outside of the circle. Okay, I have two arcs created here. One, the bigger one here, which is 26. The smaller one here, I don't know what that is. I'm going to find that before I do anything else. How am I going to find it? Well, remember a full circle is 360. If we put our big arc and our little arc together, since these are tangents, that's my whole circle. So if I take 360 degrees, subtract the 226 that's already there, that will tell me how much is left for my remaining arc. And when I do that, I get that there are 134 degrees left for this arc. So this arc is 134, this one is 226. Now I can figure out my problem. Again, its vertex is outside of the circle, so that means the angle is going to be half of the big arc minus the little arc. Put your information in. So what's my angle? My angle in this case is x. Equals 1/2 of what's the bigger arc? The bigger arc was 226. Minus the little arc. What's the little arc? It is 134. We figured that out. Okay, now we just have to do the math. So we take 226 minus 134, which gives us 92, and divide by 2. So we were able to find that x is 46 degrees. Okay, so sometimes you have to do a little step beforehand. Sometimes, like the one up here, you have to really watch to see what you're given and what you're looking for. All right, here's one more. So again, we're asked to find the value of x. So we look at what do we have in this situation. We have an angle with the vertex outside of the circle. When it intersects, this angle intersects the circle, we have one arc here and one arc here. Both of them we know. Again, angles outside the circle, so we use the formula that the angle is equal to half of the two arcs subtracted. And again, always do the bigger arc minus the smaller arc, or you're going to get a negative number. Fill in the information you have. So x was my angle, so x goes here, equals 1/2 of, what's the bigger arc? Well, 145 is larger than 63. Minus the little arc, which is 63. We'd go ahead and do our subtraction. 145 minus 63 is 82. We get x equals 1/2 of 82. 82 divided by 2 is 41 degrees. And we have solved and found x was 41 degrees.